Hello, and welcome to today's webinar. My name is Adam Golov, Marketing and Communications Manager at Data Conversion Laboratory, and I'll be your moderator today. Before we get started, I wanted to let you know we will allow time at the end of the webinar for questions and answers. So please write your questions in the chat area as they come to mind. If we don't have time to answer them all, we will make them available on our website. For those of you who are not familiar with DCL, we convert and organize content to create electronic documents, populate databases, publish on the web, and basically get it ready for tomorrow's technology. DCL services help you refine your document conversion strategy, identify document redundancy, extract metadata, and transform legacy and future documents for real needs, today and in the future. Today we are thrilled to introduce Elliot Kimber, who is a founding and active member of the DITA Technical Committee. Elliot was responsible for the majority of the new proposals in DITA 1.3, although not necessarily the most interesting ones. He has been working with structured documents and complex markup for over 30 years. He is a founding member of the W3C XML Working Group and an editor of High Time Second Edition. Elliot is the founder and primary contributor to the open source DITA for Publishers project and author of DITA for Practitioners. Elliot lives and works in Austin, Texas. Without further ado, welcome Elliot.
Thank you, Adam. All right, so today we're going to talk about some of the more esoteric and challenging aspects of HyperDocument Management. You can see my subtitle there. It's very, seems, I don't know, highfalutin or overblown or something. Anyway, but this is really getting into the most challenging aspects of HyperDocument Management, which is definitely an issue for DITA, and how I'm trying to provide at least a view to a solution, in part as a tool that people can actually use, and in part as a suggestion to other system implementers as a way that they might go about addressing these requirements. All right, so what am I talking about today? And just a little background. So I originally developed this presentation for the Balasage conference, which is an XML technology conference, but it's not a DITA-specific conference. So there's a little more DITA background here than I might need for this audience. Anyway, so what am I talking about? Link management and configuration management. So there's a lot of parts, and when you start getting into certainly in DITA content, thousands of topics and dozens or hundreds of maps and different versions in time and products with different versions, it can start to get pretty interesting. And of course, then there's DITA. So of course, we have to make sure we know which DITA we're talking about. And if you've seen some of my presentations in the past, you know that I try to make a connection between DITA and Aikido, which is a martial art that I study. So the last picture there is Saotome Sensei, who's the head of the Aikido school that I happen to train under. Anyway, so we'll talk a little bit more about that in a bit. I should also warn you that there is some poetry in this presentation. So hopefully we'll make some sense. All right, I'm going to talk a little bit about the solution implementation, that is the system I'm trying to build that actually tries to address some of these requirements. So there's a lot going on. If many of you are Star Trek nerds like I am, that's Spock from the episode, gosh, what was that episode title? The one where they go back in time to the 30s, and Spock talks about trying to basically make a 23rd century tool using stone knives and bear skins. And that's the way I kind of feel some days. All right, so let's talk about link and configuration management. So what's the problem? So the fundamental challenge here is, as an author, what can I link to, and how do I address it? That is, how do I actually construct the link so that it will work over time? If I'm an authoring tool, I need to know, especially for indirect addresses, what does this indirect address point to? Because you'd like to be able to show, you know, make that link active, show what's at the end of it, give some preview of that link. Right? That's a challenge for authoring tools. If you're producing deliverables from your content, you need to know what is the set of resources that are required in order to produce a deliverable from the input publication source, right? What are all the source files, what are the graphic files, anything else that I might need, right? I need to know those. And as a manager, and here I mean a human manager, right? What's the version-specific configuration of the publication that I'm going to get in a specific repository access context? I'll talk more about what I mean by repository access context. But basically, am I going to be delivering the correct content for whatever the current needs are based on how I'm accessing it out of my content management system? So what is the essential issue, right? So given a collection of source components that have links and that are managed through some sort of asynchronous revision process, what is the time-specific configuration of those components at any moment in time as viewed by a given agent for specific purpose? This is my sort of formal statement of the fundamental challenge of HyperDocument management. But what does that really mean? Right? So in DITA terms, what this comes down to is when I'm processing a map in a specific access context, what do I see and what can I see? Because what I see and what I'm allowed to see are two different things, but they're very related. By specific access context, what I mean is, for example, you know, as a specific user accessing a specific version of the route map or using a specific branch in my version control system, or accessing it using a specific set of access parameters or conditions or whatever, right? So if you think about a DITA map, for example, I can have different versions in time. I can have different filtering conditions applied to it. I might have different access control rights based on the user that I am, and so forth. So there's many different things that can determine what you actually get to see at any moment in time when you access something, right? It's not as simple as here's all the files and you know, this is what they point to. All right, so time for a poem. Time present and time past are both perhaps present in time future, and time future contained in time past. If all time is eternally present, all time is unredeemable. What might have been is an abstraction, remaining a perpetual possibility. Only in a world of speculation, what might have been and what has been point to one end, which is always present. That's from T.S. Eliot's The Four Quartets, Burnt Norton. So you can see there's a little bit of a linking and information and HyperDocument management theme there. I know T.S. Eliot was deep into document management technology when he was writing these poems. All right, so a little background. So first we'll talk about Aikido. So Aikido, it's a Japanese martial art, and it's distinguished in part by being purely defensive. The highest goal of Aikido is to avoid conflict entirely, but if you can't avoid conflict, then your goal is to resolve the conflict with as little damage to your attacker as possible. The ultimate goal of Aikido is universal peace and harmony. Another interesting aspect of Aikido is that there's no one true way to do it. There's no, you know, this is what Aikido is and nothing else is Aikido. Aikido is quite the opposite, actually. You're actually expected to express your own expression and interpretation of Aikido as you develop your skills. But fundamentally, Aikido is all about connection. As a martial art, as a way of engaging with the world, you have to have connection or nothing works. And there should be an obvious analogy there with what we're doing in DITA. So what is DITA? Right? Standard application for human consumed documents, application architecture. It's optimized for interchanging and operation of content processing and DITA-specific knowledge, right? So this is the way that DITA distinguishes itself from similar standards like DocBook, for example. where other standards were not really designed fundamentally for interchange and interoperation. Interchange and interoperation were the primary driving requirements for DITA, and everything in DITA basically comes from that, as well as just basic requirements for documentation in general. But DITA is the way it is, and it's different from other standards because of the requirements for interchange and interoperation. All right, so we have specialization, we have use by reference, and we have indirect addressing. These are really the three aspects of DITA that fundamentally distinguish it. And then another interesting aspect of DITA, as it was originally designed and as it continues to be defined, is that it's designed to work entirely from a file system, meaning that you don't have to have a system with some particular magical thing in order to actually get your stuff to work. If you compare that, for example, with S1000D, S1000D says, in order to use S1000D, you have to have a content management system that implements this particular magical aspect of S1000D's addressing. Or with DocBook, you have O-links, which are cross-deliverable links, and it basically says implementation-specific stuff goes here. DITA says, no, everything is 100% defined using mechanisms that you can just write down in a file and it'll work. Doesn't mean it'll be easy to process, but it means that, you can make it work with brute force if you have to. And then finally, of course, DITA is all about connection, right? Maps and topics is all about hooking things together. Content reference is about hooking things together. All right, another poem. If you have not linked yourself to true emptiness, you will never understand the art of peace. And that's by Morihei Ueshiba, the founder of Aikido, as translated by John Stevens. So of course, linking and Aikido very, very closely associated. All right, talk a little bit about addressing, because we're talking about hyperlinking, and hyperlinking depends, of course, on your ability to point to things, that is, to address them in one way or another. There's two forms of address, indirect and direct. So direct addressing, it's quick, effective, and fragile. So by direct address, I mean, of course, URL references, ID references, things like that, right? A direct reference to a thing, no intermediary. Relatively easy to learn and execute, right? I mean, even, your grandmother may know how to, type in a URL or put that in an email and have it work, right? It's something that you can learn. The challenge, of course, is that it's quick and easy, but the response is predetermined. That is, a direct address can really only do one thing, and that is get you to the thing it points to, and nothing else. And of course, here I'm being a little bit hyperbolic, I suppose you would say, but death results. And here to bring it back to martial arts, if you think of martial arts like karate or taekwondo, which are really focused on basically meeting force with force, the ultimate result is, somebody gets hurt really badly. I mean, that's just sort of the only way it can end at its worst, right? So I'm being a bit hyperbolic here, but death results. In the context of document processing, the problem is that direct addresses, because they're fragile, because they can only point to one thing, will always eventually break. Something will change and will cause those references to break. And a broken link is very, very bad. Now, indirect addressing. So indirect addressing allows you to redirect to the appropriate target, right? Because you're going through the indirection, you have an opportunity to change what's between the initial reference and the target so that you get to something different depending on the situation at hand, right? Now, indirect addressing is harder to do and harder to implement, but it's more effective, right? Because you have more power, you have more options. There's many options at the time of action, right? So at the time you're resolving the address, you might be able to, for example, have a dynamic function that, either takes the state of the system at the time or additional parameters that the user provided or, whatever it is to determine where that reference is going to resolve at this particular moment. I'm not limited to simply what the original author pointed to and nothing else. And ideally, death does not result because, we have options that are not as severe as the direct result there. And of course, Aikido is indirect addressing fundamentally. And Aikido is all about blending, redirecting, helping your attacker return to harmony. That is, getting to the thing that you're not necessarily pointing to originally, but that you need to get to now. And hopefully, I haven't pushed that analogy between Aikido and linking too hard. But I know I have to do it. All right. So indirection is necessary for survival, right? So direct addressing is preferred for delivery. And so by delivery, I mean, for example, putting HTML up on the web. And that's why you don't see any indirect addressing mechanism in any of the W3C standards, for example. Right? I mean, other than domain name resolution and the ability to have like server-side redirects, there's no way to author HTML with built-in, defined at authoring time, indirect addresses. And that's because indirect addresses at delivery time don't make sense. They just add cost. But, right, so, right, direct addresses are fast, they're uncomplicated, they're reliable. Once you've published your content and you know where everything is, your direct addresses can continue to work, right? As long as you don't remove something or move something around, everything, the addresses as published should work. Indirect addressing is required for authoring. And this is a distinction that I think a lot of people, especially in the web community, but even in the technical documentation community, don't fully appreciate. That there's a fundamental difference in requirement between addressing as used for delivery and addressing as used for authoring. And in an authoring context, indirect addressing is required, right? So it's flexible and it's robust, but it's complicated, right? So anybody who's tried to work with DITA keys understands that it is both flexible and complicated, right? And that's the nature of the beast. The link must live to link another day, right? So you author a link, you write down in a topic, a content reference, or a cross-reference. At the time you author it, that link works, presumably, right? You know what you're pointing to, all your data is there, your authoring tool or your content management system is able to resolve it. Time goes by, the content changes, you would like that link to continue to work, to not have to go back to your source, modify the address, just because other things outside your topic have changed. Right? That's what we mean. That's what I mean by the link must live to link another day. Right? And that's what indirection gives us, is the ability to have the links work over time as things change. Right? So the indirect addressing allows binding the same address, that is, whatever you wrote down in your topic as your initial pointer, get that to resolve to different targets in different use contexts. And we'll talk about that in more detail, but fundamentally what I mean here is I have a topic, that topic has some links out of it. When I use that topic in different maps, for example, I would like that link to continue to work, whatever work means in the context of each of those maps. Right. So without indirection, there are many authoring and configuration use cases that simply cannot be satisfied, right? Because you need to be able to have the same link as authored resolve to different things in different use contexts, right? In different maps, for example, right? And we would prefer to have a standard and interoperable way to do indirect addressing, right? You can always think of some way to, you can come up with your own solutions that'll work in your environment. You can implement it in your own code to make that work. There's no implementation difficulty there. The challenge is then that's not interoperable, right? DITA is all about interoperation, and standards and XML in general are all about interoperation and interchange. So we'd like to have some standard interoperable way to do indirect addressing. All right, so talk a little bit more about different use contexts. So we have the same component used multiple times in the same HyperDocument, right? I might have the same task might appear multiple times because it's, used, it's a subtask of different procedures that happen to share the same task, right? I might have the same component used in different HyperDocuments, right? I might have product A and product B share some components so they share some topics. But I might have the same component used in different versions in time of a different HyperDocument, right? So I've got the version of the doc for, version 2 of my product and the version of the doc for version 3 of my product uses the same topic. Then the question becomes, which version of that topic do each of those two versions of my publication use, right? They might use the same version, they might use a different version. So we have these three different ways of, three different use cases for use context. And here, by use context, I'm specifically, in a DITA context, topics as used by maps, right? So DITA maps and topics, this is a DITA audience, we should all know this, right? Topics are the XML documents that contain our content, right? So in DITA, all content is contained by topics, right? There's no other thing defined by DITA that can contain content. And topics are intended to be more or less context independent, especially if you're applying more formal technical documentation practices where you want your topics to be truly standalone and able to be reused more or less without concern for anything else. Right? Then we have maps. These are XML documents that contain nothing but links. Right? So a map, a DITA map, is nothing but a collection of links to either other maps or to topics or to non-DITA things, right? Because I can have maps that link to non-DITA resources, PDF pages, web page, PDF files, web pages, whatever it might be. Right? Okay. Basic DITA stuff there. All right. So now we're going to talk about DITA keys. Right? So keys are defined in maps. The key definition binds a key name to a resource, right? So a resource meaning anything you can point to using a URL. And that resource can be a topic, it can be a map, or it can be a non-DITA thing, right? So a non-DITA thing, image, website, anything that's neither a map nor a topic is by definition a non-DITA thing, and I can point to it using a URL. Right? And of course, the same key can have different bindings, same key name, can have different bindings in different maps. Right? And that's an essential feature of this indirection and why we have this facility, right? And certainly with DITA 1.3, a key reference can be used any place that a direct URI reference is allowed. So basically, any place that I've authored a direct URI reference, as a cross-reference, as a content reference, as a topic reference, I can replace that with an indirect key reference and get the same published result. Right? That is, if I point to resource A with a direct URI and I point to resource A through a key, when I publish, I'm going to get the same. I should get the same exact result for the direct URI reference and the indirect URI reference. Okay, so that's where our background here is. We have DITA documents. DITA documents are by their nature HyperDocuments. So one of the things. Let me step back a second. So in my career, I've focused really for about the last 25 years on HyperDocuments in general. That is, collections of documents that are linked together, published as a unit in some way for some purpose. And beyond that, HyperDocuments that are authored and managed through asynchronous revision processes, right? And by asynchronous, I mean that different components of the HyperDocument will be updated at different times, without necessarily any particular coordination among the parts. If you think about just how you author your DITA content today, you're not like all authoring your topics and then all committing your changes at the same moment in time, right? People are updating stuff all the time. That's an asynchronous revision process. Over the course of my career, I've worked in many different environments: technical documentation, aircraft, legal publishing, traditional publishing. That's given me a pretty broad insight, an exposure to the broad range of requirements and use cases. The one that drove the model that you're seeing here, and then I'm going to talk about in more detail, was the process of authoring and managing and publishing legislation as developed by a legislature consisting of two different houses, right? Typical American legislative model, you've got usually like a House and a Senate. They work in parallel, and come together at different places in order to develop legislation. Very challenging problem. All right, so out of this experience, myself, along with my colleague John Hines and a few other people as well, developed this model, this abstract model that we call snapshot-based configuration management, SnapCM for short. And we've published a few papers on this over the years. And this idea basically combines John Hines' version management insights with my insights about HyperDocument representation and management. Because John came out of a world of software development and configuration management of complex software components. I came from documentation and HyperDocument management, and we came together. We came up with this idea, which we were very proud of at the time. This work was all done around 1999, 2000. All right. Like I said, driven in large part by experience with legislative document management, but also informed by certainly my experience with document sets ranging from stuff at IBM, things we did at Boeing, other technical documentation requirements as well. But what I found, and nothing I've seen to date suggests that I'm wrong, is that legislative document management workflows were the most complicated and had the hardest set of requirements of any HyperDocument management environment that I had or have seen to date. And that has to do with the fact that you've got two bodies working in parallel. They come together in conference committees, for example, and they come apart. And documents are, these bills get amended, and amendments get amended, and their revision processes and the workflows and the linking required is quite challenging, as well as the business rules around access control and visibility and being able to see what the state of this complex HyperDocument is, not just at any moment in time, but at any moment in time as viewed through a particular lens, the lens of the House, the lens of the Senate, the lens of the original drafter, who might have more access rights than the public, who can look at the same thing, right? Interesting problem. You have similar, you can see similar things in even typical technical documentation environments where you have, for example, multiple concurrent product releases that have to be maintained over time. Documentation has to be coordinated between them. If you're in a regulated industry, you have some very challenging requirements around access control, around ensuring that what you publish is correct. If you're in a safety critical environment like aircraft manufacturing, again, you have some interesting challenges. You can find pretty much all those challenges in legislative, but you likely, unless you're doing, just a few documents and just one revision cycle, you probably have these requirements as well. Whether you know you have these requirements and whether or not your system is capable of really doing what you need to do around these requirements is another question. But the requirements are probably there. All right. So branches and snapshots. So this model, this abstract model for HyperDocument management, is based on this abstract concept of a repository, and a repository contains resources, right? And your resources are the things that are going to, make up your HyperDocument, whatever they are. Right? So a repository has resources. Resources have versions, right? So a resource can have 0 or more versions in time. Then your repository has branches, and the branch is a linear sequence of snapshots. Right, so it's the branch that gives visibility to a sequence of versions that were developed, normally over some period of time. But this model is generic. You could actually construct history after the fact if you wanted to. So fundamentally, the idea is a branch represents the sequence in time of how versions were created for a given resource. And then a snapshot has 0 or more versions, right? So the snapshot is the thing that gives you visibility into the versions for a set of resources, right? And the constraint there is that on a snapshot, no two versions have the same resource, right? So a snapshot is a view of a set of resources in the formal sense of a set, meaning a unique set of, no resources duplicated on the snapshot. And then for each of those resources, there's a version that's the version visible on that snapshot. Now, if you think about this in terms of, typical version control, you can see that there's, a pretty straight mapping here from repository to version control system, from branch to branch, as you might think of it in something like Git or Subversion, and snapshot being just a commit. At the time we did this work, back in the late 90s, around the turn of the century, the most sophisticated version control system that we had available to us, or that certainly we were familiar with, was Subversion. Subversion does not have a way to do atomic commits of multiple objects, right? That is, I can't do a commit where all the objects that are committed at exactly the same moment in time. And that's a problem for HyperDocument, because if I have if I have two components, if component A links to component B and component B links to component A, if I commit A before I commit B, then there's a period of time when my system is in an inconsistent state. That is, the link from A to B can't be resolved, right? So I need to be able to commit A and B at exactly the same moment in time so that my system is always in a consistent state. And that was one of the fundamental requirements for a complete HyperDocument management system. So our snapshot mechanism gave us that. So a snapshot represents, the versions that had come into existence at a single moment in time. Right. Configuration management. Right. So one of the things that we came to realize as we were thinking through these HyperDocument problems is that it's really, as much as of anything, a configuration management challenge. That is, what is the set of things, the versions of things and sets of things and the connections between them that I can see based on my visibility context, right? That is based on the lens or the hole that I'm viewing these things through. And that's a different way of thinking about things than certainly a lot of people had thought about them, about HyperDocument management up to that time. But one of the ideas here is really trying to separate the concern of version management, that is just managing versions in time of individual resources, from the concern of configuration management, which is what is the configuration of this HyperDocument for a particular access use case, which I realize is kind of an abstract thing to say, but basically it's, when I look into the system at a particular HyperDocument, what do I actually see, right? That's the configuration. Am I looking at the version 1 stuff? Am I looking at the version 2 stuff? Am I looking at the stuff that I can only see if I have specific access control, access rights? Am I seeing what was published? Am I seeing, what's currently under development? That's what I mean by configuration management. Right. So in our model, by default, you can only see versions that are on a branch, right? So if I have multiple branches, different branches might have visibility onto different versions of a given resource, but I can only see the versions that are exposed on a branch. And then that would be the current snapshot, earlier snapshots, or later snapshots if I'm looking at a snapshot that's not the latest one. Then a link to a resource is resolved using a quote resolution policy, right? So when you, in the context of this abstract model, when you create a link, you link to a resource, and then that link gets resolved to a specific version of that resource based on the resolution policy that's in effect at the time you resolve the reference. Now, if you think about that, that's an indirect address, right? That's functionally identical to a DITA key. Right? A key is a reference to a key is a reference to the abstract name for a thing, where what you actually get depends entirely on the conditions that are in effect at the time you resolve that key reference, right? It's exactly the same idea. We just defined it in a more abstract way. So the resolution policy behind that could be any number of things, right? The simplest resolution policy is on snapshot. That is, I've accessed a specific snapshot on a specific branch. When I resolve my reference, I'm going to see the version of the resource that's visible on that snapshot, right? That would be what you normally get. And that's what you get in a normal system, like for example on the file system, you know, if I'm looking at files on the file system, the only snapshot I can see is the current one. The only branch I can see is the current one because that's all there is, right? If it's, you know, there's only one copy of the thing that's available, there's only one thing I can resolve to. But if I'm doing this in the context of a content management system that has multiple branches, multiple versions available, I might be able to resolve, you know, my reference to a resource to different versions dynamically under the covers. But what you would normally expect is to get the version that's currently visible in your current snapshots. That is the latest, which really translates to the latest version. Right? Bring all this together, what this becomes is a snapshot represents a version-specific configuration of a set of resources, right? So I have a set of resources representing all the things that my HyperDocument needs, right? All the maps, all the topics, all the images. There's going to be versions of those. Those versions are linked to by my snapshot. Therefore, that defines a configuration of that HyperDocument on that snapshot, right? Because it defines what I can see based on my default resolution policy. All right. So that's just a small taste of this abstract HyperDocument model. There's more to it than that, of course, but that's the basic idea. So DITA for small teams. So we worked on this stuff, oh gosh, 17, almost 20 years ago now. Since then, I've tried several times to implement systems that reflect this model. And I have implemented systems that reflect this model, and for various reasons, some bad, some good, those systems have never survived, usually having to deal with companies getting bought and sold and that sort of thing. We have implemented the model in the past, and I know the model works, and I like my model. And I've always wanted to have this model be available in a DITA context, right? Because fundamentally, DITA has become the standard that provides the HyperDocument authoring, management, delivery mechanisms that I've always wanted, and that we tried to standardize in the 90s in things like high time and in some of the W3C standards like Xlink. DITA ends up being the standard that actually has all the linking stuff into it. I mean, one of the ways that you can think of DITA as a very sophisticated HyperDocument standard based on XML, and oh yeah, I can use it for technical documentation. Yeah, that's interesting. But what's really interesting is that it's really HyperDocuments, right? That's how I think of DITA, because I've been thinking about HyperDocuments my entire career. Realize most people think of DITA as a way to author their documents, but I think of it as really being about HyperDocuments. So I wanted to apply this model to it. Nobody's done it. No content management vendor, including the ones that I've worked for in the past, really embraced this model, and it just frustrated me no end. And now I'm a bitter man. But I realized that I could actually implement this model on top of more modern version control systems fairly quickly and easily. I had that insight, I don't know, 4 or 5 years ago. About 3 years ago, started to realize that open source tools had gotten to a point where it was now possible to bring together different open source tools and without too much effort, cobble together a system that would allow you to author, manage, and publish your database content in an environment where you basically had no budget, right? The 2 or 3 person technical writing team that gets no love, that's seen as a cost that nobody wants to fund, and they don't get any money for tools. Nobody's going to, put down $500,000 for a content management system for you. Right? It's not going to happen. So out of that came this project DITA for small teams. And then out of that, realized that the linking management, the link management component was the one thing that was really missing. So that gets me where we are. So if you think about the system that you need to manage, author and manage your content, right? You need some kind of version content management system. You need authoring, you need production and delivery, and you need link management. The first 3 things you can find either in open source tools or in commercial tools that are affordable or are your only options, like Oxygen, XMetal, or any of the new web-based authoring systems. Production and delivery, of course, we have the Open Toolkit, some other open source tools, some commercial tools. Continuous integration systems are out there, things like Jenkins or GitLab. There are lots of options there. The one thing that wasn't there was link management. And so I've been working on this tool, DITA for small teams, Link Manager. I'm still working on, but it does actually, at the moment, works well enough to at least be able to demonstrate. All right. So yeah, so link management is the one missing piece. And I am working on that. So here's the basic DITA for small teams model. And here I'm specifically focusing on the use of Git, and we'll see why in a minute. But it turns out that Git as a version control system maps very, very cleanly onto my abstract snapshot-based configuration management system. And when I realized that a few years ago, I got very excited because I was like, oh, I can implement my model, and Git does most of the work. And that was nice. And just for history, Git was developed starting in about 2003, 2004. So our model predates Git by a number of years, but the Git guys basically, as far as I know, independently came up with the same basic approach to version management. They were, of course, more focused on specifically managing code artifacts. But the way that they think about versions and branches maps very closely to our model. So that pleased me. So basically, you've got a central Git repository that connects to your continuous integration server that's doing your publications. It also has some hooks, some commit hooks that interact with the link management repository and keep your link management information up to date. The link management repository provides a web application that gives you access to the link management information. And then in your local authoring environment, you have a local Git repository that actually allows you to do your day-to-day, minute-by-minute authoring, and then communicate things back to the main Git repository. So it closes the loop from your authoring environment to the central Git repository, back to the link management application, and back to the authors. That's the basic model. All right. So let's talk about Git as a repository very quickly. So Git's versioning model close-matches the abstract model, but of course, Git itself does not provide any branch-specific access control, right? A Git repository just says, here's all the branches. Anybody who has access to the Git repository can get that. Now, you can get the effect of having, being able to see different branches, more or less at the same time by having multiple clones that just, have checked on different branches. And of course, you can have Git hooks that feed updates to your link manager. So that ends up working really nicely. All right, so link management. So this is really where the data processing challenge is. So what I'm implementing is a data-specific X-ray application. Right now, it's implemented on top of BaseX using XQuery 3.1. Could be implemented on top of any other XQuery 3.x capable system. Mark logic exists, whatever. Okay, so this maintains basically a where used index based on the links that are in the source document. Right? Because the fundamental question that an author needs to have an answer to, a quick answer to, is for a given information component, a topic, a map, an element that might be used by reference, where in my current information set is that, is there a link to this thing, right? The where used question. I do implement DITA key space construction and key resolution. Of course, that's a fundamental challenge in DITA. Link processing is resolving these indirect addresses. Fundamentally, this is just data processing, right? I mean, there's no real magic here. There's no real, from a software engineering standpoint, no real hard challenge. I'm not coming up with some, algorithm that nobody's thought of, or trying to implement some sort of machine learning thing. I'm just doing a lot of data processing. It's just the data processing is challenging enough, at least for my feeble programming skills. Right. DITA does have some tricky features, right? So you've got trees of maps, you've got conditional key definitions, you've got key scopes that we added in DITA 1.3, you've got branch filtering, which we added in DITA 1.3. These make the data processing challenging, but not impossible. Right? Let's talk a little bit about Git for the versioning model. So a Git branch is more or less exactly equal to a SnapCM branch, right? A Git commit is equal to a SnapCM snapshot. So one of the ways that Git is different from Subversion, for example, is that a Git commit is an atomic commit of multiple objects. When you make a Git commit, everything that's committed on that, when you do that commit, every different file has it's committed at the exact same moment in time as far as Git's concerned. And so that means that I can, if I make changes to my HyperDocument and I commit all those changes as a single commit, I can ensure that my system is never in an inconsistent state, right? Such that a link that would otherwise be resolvable is not for some period of time. So that Git having atomic commits was very important, right? The way I've implemented my link management repository is that it simply mirrors the Git repository and branch organization, because basically it's the SnapCM repository branch snapshot notion is exactly equal to the Git repository branch commit organization. As I've currently implemented things, it only reflects the current commit, the link management database does. I could reflect more commits that would just cost more storage. For example, I might have, maintain information. If you create a tag in Git, that might be worth saving as a separate commit, right? As opposed to saving the history of every commit that's happened over time, because that would start to use a lot of storage. But yes, this atomic commit is the key that allows the creation of a link management system that's reliable in the sense that you can ensure that it's never in an inconsistent state. All right. No key magic. All right, so implemented with XQuery database. Depends pretty heavily on XPath 3.1, which adds maps and arrays. And it would have been much, much more difficult to implement this processing in XQuery if there weren't maps. Because if you think about T and T spaces, these are basically huge maps of names to resources. Right? I'm not going to go into too much more detail here. I think we're sort of out of time. Basically, the challenge here is how to create a where used index. And the way I did that is I create these where used records, which are simply XML documents that capture what points to what. For each document that is pointed to, there's a directory in the where used index. If a document doesn't have a directory, it's not used by anything. If it does have a directory, then it is used. That allows me to very quickly answer the question, is this document or is this element used by anything, yes or no? Very, very quick answer to that. If you didn't want to know, all right, well, what uses it, a slightly less quick answer, but still pretty quick. All right, so implementing direct links, pretty straightforward. You just find all the links, you resolve the addresses, because they're just URLs, and then you create, this is what my reuse record looks like. Indirect links, this is where the challenge happens. One of the things that I have to do is generate resolved maps, right? So I have to resolve all the maps, create a single map so that I know I can then construct all the key spaces and know what's in the map, what's not in the map. That's a challenge, but it's doable. And then I do a lot of stuff, find all the indirect links, right? So anything that has a key reference or a con-key ref, that's an indirect link, resolve all those indirect links, and now I can create my use records. And that's basically the data processing challenge there. All right, I have a link management web application, uses a quasi-standard called RESTXQ, which is a way of defining REST APIs and web applications using XQuery in a way that's very similar to how you would do it, say, in Java or another language. It was quick and easy to do. And my application can report on pretty much interesting about the link aspect of the content. I do actually have a demo that I could show very quickly, but we are close to the end of the time, and I wanted to make sure that there was some time for questions. So we've got about 10 minutes. So I'm not going to show anything unless somebody really wanted to. I will be talking about this next week at DITA North America, and I will be giving a demo there. And of course, you can actually download the system and run it yourself if you want to. All right. So what was easy? Using Git for the HyperDocument source management, that ended up really being easy, and that's why I took this route at all, because it would be easy. If it had been hard, I wouldn't have done it. Just because this is sort of a spare time, nights and weekends project. I chose BaseX because it was easy to set up. Direct address resolution, of course, was easy. Data map resolution was relatively easy, partly because I ignored the harder parts. What was hard? Key space construction. It took me a while to get my head around maps in XQuery 3.1. And I don't have a good XQuery IDE development environment that would support implementing this code. That may be there now. I started on this a couple years ago. Scope keys add data processing complexity that I'm still struggling with getting around that. But that's just because I'm not that strong of a programmer. All right. And XQuery update does not allow naive approaches to the link management database population. So it took me a while to get my head around how you actually keep things up to date. Yeah, I worked it out. All right. So what's still to be done? So need to finish out the data key space construction. So I knew I need to implement key scopes and branch filtering, and more dynamic conditional processing. That would be an interesting challenge. Finish out the basic link management reporting features. Right now, there's a number of things that I have like buttons for in my link manager application. Don't actually do anything because I haven't gotten that far in my implementation work. Another important aspect of this that I haven't started on yet, but that I definitely intend, is to have a REST API for accessing link management information from other applications. So, for example, if I have, in an authoring application, I'd like to be able to have my authoring tool talk directly to the link management system to get, the link information, so it doesn't have to reconstruct all that itself, or from other, from output processors or whatever. Can easily provide a REST API for that. I just haven't done it yet. Packaging everything up as Dockers, that's now pretty well there in the DITA for Small Teams Docker project, and then some tighter integration with authoring tools. Right now, I don't have any real tight integration. And better error reporting for link management data processing. So when you're processing these documents, if things are not authored correctly, or there's some link that can't be resolved. Right now, I don't really have a good way of reporting that. I need to make that better. Oh, and of course I need to document it. All right. So that's where we are. So any questions?
Well, thank you, Elliot. A very formative webinar indeed. The first question that's come in is a rather long one, so please bear with me. Keys haven't been widely adopted in my group, even though we see the benefits of them. It's largely because of the time to convert our current direct references to indirect references. We don't necessarily want two referencing mechanisms for inconsistencies, so we continue to live with direct content references. Do you have recommendations on how to move away from direct to indirect references and manage getting links changed over?
Yes. So, I've done this kind of conversion for some clients, and especially if if your file names are unique across your entire content set, it can be pretty easy to run a transform that will basically generate keys. So basically for every topic you generate a key definition, and then for every link to those topics you replace the direct URL reference with a key reference, and everything just works the way it did. That's a fairly straightforward transform to write like as an XSLT transform, but it does require, the details are going to depend on your particular document set, right? And conventions that you've used or details. The other more challenging aspect is that if you follow my recommendation, that you also put keys on your navigation topic refs, there may not be a good way to automate that because of reasons that we don't have enough time to go into. But basically, you want the keys that are on your navigation topic graphs to make sense in the context of the document itself. You know, like the logical and rhetorical structure of the document, as opposed to just having keys that basically reflect the original file name of your topics. So that's a larger challenge that may require, you know, actual editorial work. And depending on the nature of your content, there may not be an easy solution there. So really what it comes down to is this is something you need to plan for and probably dedicate, you know, some amount of time, either, you know, depending on the size of your documentation set and the schedules that you have to release things, you know, either just, you know, spend a week or two and just go through everything and make that conversion one time, eat that cost, and then go on, or, you know, do it on a publication by publication basis, automating as much as you can. That's about the best I can do as far as recommendations go. But yeah, I mean, there's no way to avoid the one-time cost of making the conversion, right? There's no easy way out.
Great, thank you, Elliot. The next question that has come in is, have you tried working with JSON artifact instead of XML? What would be the advantages of moving to JSON?
Well, the short answer is no. I've not worked with JSON. Certainly not in this context. I mean, I wouldn't consider JSON for documentation authoring. Right? I mean, I just wouldn't do it. JSON is useful in other environments, like, you know, communication of servers to web clients, or just general interchange of, you know, piles of structured data. But as an authoring source format, it's a non-starter.
Thank you, Elliot. The last question that has come in is, do you need any help building out the rest of your LM system? Documentation, executing, coding, etc.
Yes, the short answer is yes. I'll take any help I can get.
Great, thank you, Elliot. Do you have time for one more question?
Sure.
Okay. The last question that's come in is, can you say a bit more about resolution policies and what does this mean in a DITA context?
Sure. So the way that the DITA standard is defined is, even though you have indirect addressing, right, you have key definitions, what the key definition points to is still statically defined. So ultimately you get a direct URL reference. But if you imagine that you replace that direct URL reference with a URL that is itself a query, then the key resolution can become quite dynamic, and that query could take parameters that are provided at the time you do the key reference resolution, right? And so in that context, your resolution policy becomes, what are the functions that I can access through these, you know, basically URL queries? What are the parameters, and what choices do they allow me to give? For example, I might want to be able to say, well, at the time I resolve this key, you know, the user has gotten to this documentation through a system that forces them to say, you know, I'm an expert user, I'm using this version of the product, I'm on this operating system, you know, a number of different conditions that serve to characterize that user. I'd like to resolve this key dynamically using these values that come from the current, you know, the current user is specified as input queries to my system, so that I actually find the right topic more dynamically by querying against a whole set of topics rather than just having a predefined set of hard-coded URLs. That's what I mean by resolution policy. The resolution policy could also take into account things like a user's access rights. You know, if you're in a controlled situation or you know, an environment where you might have security concerns, that might be a way that your resolution policy, you know, basically, I've got this direct URL, but you know, my security status, my security clearance is only internal use. So if it's confidential, I can't see it, even though the URL points to it. Right? That would be another example of a resolution policy applied at key resolution time.
Great. Well, thank you, Elliot, and thank you, everyone, for attending today's webinar. This will conclude today's broadcast. You will be able to access the recorded version of this webinar in the archive section, webinar section of our website located at www.dclab.com. Also, our next webinar will be Tuesday, May 2nd at 1 p.m. Eastern Daylight Time, titled Generating Revenue, the Hidden Connection Between Content and Product Strategies, being presented by Ishita Grover, Senior Manager of Technical Communications at Cisco Systems. Thank you, everyone, for attending, and have a great day.
Thank you.